Without telescopes or modern technology, this civilization managed to calculate the trajectory of planets and eclipses with remarkable precision. Their records were used for centuries. Since ancient times, societies have looked to the sky for answers. The stars, the moon and the sun served as a reference for measuring time, organizing agricultural cycles, and interpreting the world. In the Babylonian civilization, however, the study of the sky went beyond casual observation. It became a system of recording and prediction that laid the foundation for scientific astronomy. Their scribes, the guardians of knowledge, in addition to having documented the patterns of the sky, also developed mathematical methods to anticipate astronomical phenomena. Its most everyday influence is in the way we measure time. The Babylonians used a sexagesimal system, based on the number 60, instead of the decimal we use for most calculations. Thanks to them, today an hour has 60 minutes and a minute has 60 seconds. A millenary astronomical legacy. Unlike other civilizations that saw the stars as gods or spiritual entities, the Babylonians began to analyze them in a systematic way. They observed that the stars maintained fixed positions relative to each other, forming constellations that followed annual cycles, while the planets moved more erratically. They also recorded eclipses, changes in the luminosity of the moon and the movement of the sun throughout the year. These studies were fundamental in Babylonian daily life. The measurement of time depended on the sky. A month corresponded to a lunar cycle and a year to the path of the sun. But his interest went beyond practical utility. They believed that changes in the stars could herald events on Earth, from prosperous harvests to political crises or natural disasters. The meticulous record of the sky. The Babylonian scribes took their observation to an unprecedented level. They documented their findings in key texts such as the Mul. Abin means star of the plow. This kind of book was a compilation of astronomical knowledge that included lists of stars, the rising and setting of the stars at different times of the year and the movements of the moon and the planets. Later, they began writing the astronomical diaries, detailed records that covered more than 700 years. In these documents they accurately noted the position of the moon and planets, along with terrestrial events such as grain prices, weather phenomena, and political events. Their goal was to find patterns between the sky and the earth, in an attempt to predict the future from astronomical observation. The development of astronomical prediction. One of the most important advances of the Babylonians was the creation of a system for predicting celestial events. They found that certain phenomena followed repetitive cycles, which allowed them to accurately calculate when they would occur again. They identified what they called goal years, the time it took for a planet to return to the same position in the sky. For example, they determined that Venus repeated its trajectory every 8 years. With these calculations, they were able to develop ephemeris, tables that indicated the exact date of future astronomical phenomena. This method of prediction was a milestone in the history of science, as it was not based on religious interpretations or mythology, but on empirical data and mathematical formulas. Babylonian astronomical knowledge is not a thing of the past. Greek astronomers used their records to create geometric models of planetary motion. His calculations were the precursors of the astronomical tables that continued to be used for centuries, and that continue today in resources such as NASA's eclipse table.